Welcome to the explainer. It's one of those things we use all the time. Selenium WebDriver. But have you ever stopped to wonder how it actually works its magic? Today, we're going to pull back the curtain and really dig into its secret architecture. So let's get started.
So let's start with the central puzzle, right? On one hand, you've got your script. Maybe it's in Python or Java or C#. And on the other hand, you've got a web browser like Chrome. These two things are completely separate, built by different teams, written in different languages. So how on earth does a command in your code make the browser actually do something? It's a classic communication problem.
To really wrap our heads around this, we're going to use an analogy. Let's think of it like a diplomatic mission. Your command is a super important message, and it needs to get from your government, that's your script, to a foreign head of state, that's the browser. And as you can imagine, there are a few key players involved to make sure that message gets delivered correctly.
Okay, so player number one is your script. This is our diplomat. It's where you write your instructions, right? You use Selenium's client libraries to say things like, find this button or click this link. Your script has the message. It knows the intent. It knows exactly what needs to get done.
Now, our diplomat can't just shout the message across the border. It needs to be packaged up securely in a way that everybody involved can understand. And that's where the JSON wire protocol comes in. This thing is basically our diplomatic pouch. It takes your command and wraps it up in a universal format. That format is JSON, which is just a simple way to structure data, and it's sent over a standard web request using HTTP. So once that diplomatic pouch arrives in the foreign country, it needs a translator. And this, right here, is probably the most crucial player in the whole operation, the browser driver. You see, every browser has its own special driver. Chrome driver for Chrome, Gecko driver for Firefox, you get the idea. Its one and only job is to open up that pouch, read the message, and translate it into a language the local browser will actually understand.
And that brings us to our final player, the foreign head of state, the browser itself. After it gets those perfectly translated instructions from its driver, the browser just does the thing. It clicks the button, it fills out the form, it goes to a new page. Mission accomplished.
So now that we've met all the players on our diplomatic mission, let's actually follow the journey of one single command, from the moment you write it to the moment it happens on screen. We'll see how this all unfolds in 5 pretty clear steps.
All right, so here's the roadmap for our command's journey. It all starts with you, writing the directive in your code. Then, that directive gets packaged up, sent over to the translator, our driver, and then, finally, it gets executed. But wait, there's one more crucial step. The browser reports back, which completes the whole cycle. Let's break that down just a little bit more. So right off the bat, when you run your test, the Selenium client library in your code doesn't actually talk to the browser. Nope. First, it takes your line of code, something like driver.findElement, and it turns it into a JSON object. This little package of JSON is then fired off as a standard HTTP request. That HTTP request, with its JSON payload, travels across your local network to the browser driver, which is just sitting there listening for instructions. The driver catches it, reads the JSON, and goes, "Aha, I see what's happening. They want to find an element with this specific ID." It then uses its own internal, secret knowledge of its browser to make that happen.
And here's the beautiful part. This is a two-way street. It's not just about sending commands. After the browser tries to do the action, it sends a status report back to the driver. Yep, I clicked the button. Or maybe, whoa, I couldn't find that element. Here's an error. The driver then packs that response back into another JSON object and sends it all the way back to your script. The loop is complete.
We've been talking a lot about how important these translators, the browser drivers, are. So let's take a closer look at them. Because, every browser is a little different, and this is definitely not a one-size-fits-all kind of job. Now, what's really cool about this is who maintains these drivers. Take a look. It's the browser makers themselves. Google maintains Chrome driver, Mozilla takes care of Gecko driver, and so on. And when you think about it, that makes perfect sense, right? Who knows how to talk to Chrome better than the team that actually builds Chrome? This is what ensures those translations are always spot on. Okay, so we know the messages are sent as JSON over HTTP. But
What is this system of rules? I mean, this isn't some weird custom thing Selenium invented. It's actually built on a rock-solid foundation that powers, well, pretty much the entire modern web. The universal language here is a REST API. We've probably heard that term thrown around. And really, it's just a standard way for computer systems to talk to each other over a network. At its heart, Selenium WebDriver is just a REST API. The browser driver has a set of endpoints, and your script makes requests to them. It's that simple. And that's the big reveal. All this complexity we've been talking about, it all boils down to this one simple idea. When your code runs a command to find an element, it's really just making a POST request to a specific URL. When it gets the text from that element, it's making a GET request. It's all just web traffic, the exact same kind your browser uses every single second.
Okay, so that was a lot of technical detail. But why should you actually care? Why is understanding this whole diplomatic mission useful for you as a developer or a tester in your day-to-day work?
Well, it matters for a few huge reasons. First, it makes your setup way simpler. Once you know you just need the right driver for the right browser, configuration just clicks. Second, it makes you a debugging superstar. When a test fails, you can ask the right questions. Is the problem in my script, the driver, or the browser? Third, and this is a nice little bonus, this stuff comes up in job interviews all the time. And finally, and maybe most importantly, this architecture is what makes Selenium so flexible. It's the reason any programming language can talk to any browser. It's just a beautifully designed system.
So at the end of the day, Selenium's architecture is just this really elegant solution to a tricky communication problem. It's this whole team of diplomats and protocols and translators all working together to get a message delivered. So now that you know exactly how they talk to each other, the only question left is, what are you going to tell them to do next?